For the first part of the lab, you will need petroleum ether. You'll also need a mixture of petroleum ether and acetone. So in particular, this mixture is 70% petroleum ether and 30% acetone. You'll also need sodium sulfate. You'll need some cotton with tweezers and a copper wire. You'll see why in a bit. You need some clean pipettes. You also need some test tubes, some centrifuge test tubes, and then a cork that fits into your regular test tubes. So we'll show that step later. Of course, you need some spinach for the spinach lab. You'll need a thermometer clamp, although we're not going to hold a thermometer, we're going to hold a pipette. You need some acetone, and then you'll need a scoopula with a weigh boat, as well as some water on a hot plate. Now, I'm not showing quite everything you need for part 1, but we'll see those other materials as we go along. First, I'm going to weigh 0.5 grams of spinach. So I'm going to use my balance and tare a weigh boat or zero a weigh boat. And then I'm going to try to get as close as possible to 0.5 grams of spinach. You can find the actual amount that I weighed on the lab assignment page. So you can see this has already been chopped up for us, which is great. And I'm just going to use my scoopula to add some to the weigh boat. Next, I'm going to try to get all of that spinach into a regular test tube. This can be a little bit challenging, so I'm going to use a small spatula to help me with this process. So initially I tried to pour the spinach into the test tube and that did not work, so I just used my hands and I packed the spinach into the test tube little by little, and then I used the spatula to push the spinach down to the bottom. So this took me a while, but eventually I got all of the spinach into the test tube. Once all of the spinach was transferred to the test tube, I added 2 milliliters of acetone to the same test tube. This is going to help extract the pigments that are found in spinach. You can already see that the acetone has turned a light green color. Next, I placed a cork in the top of the test tube and shook the spinach with the acetone for 5 minutes. Vapors can build up, so I was holding the cork carefully. Eventually, I did add some tape to my cork just to create a better seal. But after shaking for 5 minutes, you can see that the spinach and acetone are at the bottom of the test tube, and the acetone has absorbed the chlorophylls and carotenes and other pigments from spinach. In this next step, I'm going to use a pipette and pipette bulb to transfer the acetone with the dissolved pigments into a separate clean test tube. So this can be a bit tricky since the spinach is still in the test tube as well, but you can see that the acetone I'm transferring is now a nice dark green color, whereas initially it was just a light green color. So shaking the test tube really helped to extract those pigments from spinach. Now I'm going to add 2 milliliters of petroleum ether, which is an organic solvent. And the organic solvent is going to further extract the pigments that we removed from the spinach. So here you can see there are two layers that have formed. We have an acetone layer and a petroleum ether layer. Now I'm going to shake this test tube for 1 minute with the cork on top. And again, I'm holding the cork very carefully so that the cork doesn't pop off from the added vapor pressure. Once I'm done shaking for 1 minute, I'm going to let those two layers settle. And now the pigments should be found in the petroleum ether layer. Now I'm going to add some water to my test tube, and this will help to remove the acetone from the petroleum ether layer, since acetone is polar. Some might be left in the petroleum ether layer though. So again, you can see two layers here. The bottom layer is the aqueous layer, the top layer is the organic layer. Next, we're going to transfer our solution into a centrifuge tube, and then we will run this sample through the centrifuge to further separate the two layers. So this is our centrifuge, and basically what you do is you add your centrifuge tube with your sample across from either someone else's sample or a centrifuge tube filled with water. That way the centrifuge remains balanced. Now the centrifuge is going to spin at a very high velocity, and that's going to allow for our layers to separate from each other, just using centripetal forces. So here I'm setting the timer for about 5 minutes, which should be enough time for everything to separate. Once the centrifuge is done, I pulled out both centrifuge tubes, and now we can see that the petroleum ether layer is on top of the aqueous layer. Next, we're going to set up a drying column, which will remove any water from our sample. So what we'll need is a pipette, and then the cotton that's behind us, as well as sodium sulfate, our drying agent. So the first thing I'm going to do is place a little bit of cotton in the bottom of the pipette, and that will block the sodium sulfate from falling through the pipette. So we're just creating a little barrier. So you don't need much cotton. I'm going to place it into the pipette, and then I'm going to use the copper wire to push the cotton to the bottom of the pipette. So here you can see I've blocked the end of the pipette, and next I'm going to add sodium sulfate, a drying agent. Now the easiest way to add the sodium sulfate is to just use your pipette as the scoop. So I'm going to invert my pipette, try to get some sodium sulfate in the top, and allow it to sink down to the bottom. Here is the finished drying column. Now I'm going to use a thermometer clamp to hold the drying column that I just created. So normally this would hold a thermometer, but it's also the perfect size to hold our drying column. I also set up a test tube in a beaker underneath the drying column so we can collect our sample. Now I'm going to use a pipette to transfer the petroleum ether layer through the drying column. This will remove any water molecules that might be present in the sample. So here I've added most of the petroleum ether layer. There might be a little bit left in the test tube, so I can always try to transfer a little bit more. But here we're just letting the sample run through the drying column and collect in the test tube below. Now, some of the solution wasn't quite moving through the column, so what I did was I put a pipette bulb on top of the drying column pipette, and I just squeezed the bulb a few times to push through the solution. I was struggling a bit to get the bulb on top of the pipette though. So here you can see I'm kind of squeezing the bulb and it's pushing solution down into the test tube. Now I'm going to take the sample I just collected and remove all of the solvent, so the petroleum ether and any acetone that might be left in there. The way I did this was I set up a hot water bath, so I just heated some water on a hot plate, and I'm just going to use some test tube tongs to hold the test tube in this hot water until all of the solvent has boiled off. After a few minutes, you can see that the solvent has evaporated or boiled off, and now we're left with a green sludge. For part 2 of the lab, you'll also need several items. You're going to need your sample from part 1 of the lab, so our green sludge in the bottom of that test tube. You'll need some clean pipettes, a thermometer clamp again, some cotton again. You'll also need some sand, some alumina, which will be used in our column chromatography. You'll need some solvents such as petroleum ether, acetone, and then a 70-30 mix of petroleum ether and acetone. And then you'll also need some labeled test tubes. So here I've labeled 3 test tubes with each of the different solvents, and these will be our stock solvents. So I have acetone, petroleum ether, and then 70-30 petroleum ether and acetone. You will also need some labeled test tubes for your collection of different pigments. So I just labeled these 1, 2, 3, and 4. So you'll see what those are used for later. Additionally, you might need a small funnel to try to collect alumina and sand, and then a ruler. So first we're going to redissolve our green scum with petroleum ether. So I added about 0.5 milliliters of petroleum ether to my green sludge, so we're just rediluting it. Now we're going to prepare a column for column chromatography, and this will allow us to separate all of our pigments. So I'm going to use, again, a pasteur pipette, and similar to before, I need to block the bottom of the pipette using a little bit of cotton. So here I have my cotton in the bottom of the pipette, and now I'm going to place my pipette into the thermometer clamp just to hold it in place. Now I'm going to place some sand on top of the cotton I just added. We need about 0.25 inches of sand, so this is where the ruler comes in handy. And I'm just going to measure from the top of the cotton that I just added. And this can be an estimate. It doesn't have to be perfect or exact, but about 0.25 inches. So using my small funnel, I'm now going to add enough sand so that I have 0.25 inches of sand on top of the cotton. Next, I need to add about an inch of alumina. So I'm just measuring and kind of seeing where I need to add 2, and then I can do the same thing. I can use my small funnel and scoop the alumina into the pipette. Finally, I'm going to add 0.25 inches of sand on top of the alumina. And here I was just double checking that I had enough sand on top, but I just needed a couple of more scoops. And now we have a column that we can use to separate our pigments. So here I've placed my test tube labeled 1 underneath the column, and I'm going to wet the column using petroleum ether. So I've already filled in my stock test tubes with the different solvents that I need, and now I'm just going to add some petroleum ether to the column just to get it started. So here I'm just letting the petroleum ether work its way through the column, and this is called rinsing the column. Once the meniscus for the petroleum ether is towards the top of the column, then I'm going to add about half of my pigment sample. Now we're going to let the pigments run through the column. In test tube 1, we're going to collect all of the petroleum ether up until those pigments hit the bottom of the column. Then we're going to switch out our test tube for test tube number 2. So here we're collecting fractions. I'm going to fast forward the video so you can watch the pigment travel to the bottom of the column. So at the top of the alumina, you might be able to see a yellow band starting to form. So now we're going to watch that travel down the column. The yellow band is starting to reach the bottom of the column. So now I'm going to switch out my test tube 1 for test tube 2. And I'm going to try to collect the yellow band in test tube 2. Now that the yellow band has completely disappeared, I'm going to replace test tube 2 with test tube 3. And this is going to collect any solvent before the next band goes through. The next band should be green. Here you can see the yellow pigments in our fraction 2. Fraction 1 again was just petroleum ether, and then we collected all of the yellow pigments after that. Now I'm going to switch from petroleum ether to acetone. Acetone is more polar, so it should encourage the green pigments to travel down the alumina column. And now I'll fast forward the video so you can watch the green pigments travel down. So now that the pigments have reached the bottom of the column, we're going to switch out our test tube for test tube 4. And then we'll hopefully just collect the green pigments, along with any solvent, in test tube 4. So now that we're done collecting our pigments, let's look at the test tube. All right, so we've got all of our green pigments in test tube 4, and remember we had collected all of our yellow pigments in test tube 2. So in the next step, we're going to evaporate off these solvents in test tube 2 and test tube 4 using our hot water bath. Now for part 3 of the lab. For this part of the lab, you're going to need your yellow pigments and your green pigments from the last part we just performed. You'll also need the other half of your crude product from part 1. You'll need a TLC plate, a development chamber, some capillary tubes. You'll need hexanes, and then you'll also need your solvents from the previous steps. So first I'm going to remove the TLC plate from its beaker, and we're just going to set it up using a mechanical pencil. And remember, there is a shiny side to the TLC plate, and then there is a less shiny side, and that's the side that contains the silica that we want to use. So I'm going to measure 1 centimeter from the bottom of the TLC plate, and I'm going to draw a line across the plate. This is going to be my starting point for my different samples. Now I'm going to mark 3 dots along this line, and these dots will be where my samples go. The first dot will be fraction 2 from the previous part of the lab. The second dot will be fraction 4, and the last dot will be my crude product from part 1 of the lab. Now I'm redissolving my fractions with hexanes. So this is an organic solvent that will help dissolve those fractions. And then I'm doing the same thing to my crude product from part 1. I'm just going to add a couple drops or a few milliliters of hexanes. Now I'm going to use my capillary tubes to add a little bit of each of my samples to the TLC plate. So the capillary tubes are open on both ends, and they are a little difficult to get into these long test tubes, so I'm going to use some forceps or tweezers to get the sample that I need. So once I have some sample in my capillary tube, I'm going to add a couple of drops of the sample to the appropriate dot on my TLC plate. Here I'm adding the fraction 4 sample to the appropriate spot. And finally, I'm adding the crude product sample to the last spot. Now we can add the TLC plate to our development chamber. I've already added a few milliliters of 70-30 petroleum ether, and I'm just going to dip the TLC plate in the solvent, and we're going to watch it rise up the plate. So I will fast forward the video so you can see the pigments separating. Once everything is separated, I marked the solvent line at the top, and then I also circled all of the spots I could see and marked them according to their colors or identification. You can find a picture of this TLC plate on the Canvas Lab assignment page. In part 4 of the lab, we're going to use UV-Vis spectroscopy to analyze our samples. So we're going to need our SpectroVis Plus. First, I'm going to connect the SpectroVis Plus to the computer using the USB port. Then I'm going to open up the LabQuest software on the computer. Here you can see a rainbow background. So these are the colors that are either absorbed or emitted by our samples. And they're listed according to wavelength. Now I'm going to fill a cuvette with DI water so that I can get a background spectrum and subtract it from my actual spectra. Then I'm going to place my cuvette with the DI water into the SpectroVis, making sure that the clear side of the cuvette is facing the arrow. Once I have my background spectrum, I'm going to dilute fraction 2, the yellow pigments, with some more hexanes and fill up my cuvette. And then I'm going to place the cuvette into the SpectroVis and record my absorbance spectrum. So here is the spectrum for the yellow sample, fraction 2, and you can see it's a bit noisy, but you can look at this in more detail on the lab assignment page. Once we've collected the spectrum for the yellow sample, now we're going to collect the spectrum for the green sample, which I've also diluted with more hexanes. So I'm going to place that into my SpectroVis, and we're going to record the spectrum again, but this time for the green pigments. And here is our final spectrum for the green pigments. You can see it's a little less noisy, so we likely had more green pigments in our sample than yellow, but you can look at this again in more detail on the lab assignment page. You can find all of the data, spectra, and pictures of our TLC plate on the lab assignment page. If you have any questions, please let me know.